These are the Lesson 7.2 notes on multiplying and dividing radical expressions. Today we're just going to focus on multiplication, and we're going to look at simplifying radical expressions as well. We're starting off today with some roots you should know. There are some different square roots and cube roots that you should really know off the top of your head because it makes simplifying the radical expressions a lot easier and eliminates the need for you to immediately reach for your calculator. So any of the square roots between 4 and 100 you should know. The cube roots of 8, 27, and 64 should be kind of imprinted in your memory banks as well. The cube root of 125 is 5. That should be one you know. And the fourth root of 16 is 2. These are some common ones that will come up in these problems that it's good to have according to your memory. One other one that I will also include on here but wasn't part of your worksheet originally is the fourth root of 81, and that is equal to 3. And we'll see most of these come up throughout today. We're going to start today by reviewing something we talked about yesterday, which is simplifying radical expressions. Yesterday we had this square root of 25a squared b cubed c to the fourth d to the fifth. And we were able to break this problem up into things that we know the square roots of and things we didn't know the square roots of. For example, we knew what the square root of 25 was, so that will go in here, and we can also square root the a squared. That's something we can work with. Odd powers, not so much. B cubed, we don't know the square root of. However, if we take out a b squared, because it is an even powers should be able to go into even roots. We're going to use kind of a little bit of division here, so b squared works. It does leave us with a b, however. So b squared times b is b cubed. I can square root the b squared. Can't really square root the b, the odd value. C to the fourth we can square root. However, d to the fifth we're kind of in the same boat as before. Unless I split the d to the fifth into d to the fourth, which I can square root, and then this d, which we don't know the square root of. What are we left with? Well, we know the square root of 25 is 5. It's positive, so we don't need an absolute value around it. The square root of a squared is a. Because this is like a to the first, I don't want this to be a negative value, so we are going to put absolute values around the a. And for the same reason, the square root of b squared is b. We're going to put absolute values around these things because we don't know if a and b are positive or not. Now the square root of c to the fourth, because this is a square, the square root of c to the fourth is c squared. C squared, because it's a square, is automatically positive. And the square root of d to the fourth is also d squared. So simplifying this radical expression gives me this. We're still going to multiply it by the square root of bd, and I can't really simplify this. This whole thing is our answer. Remember, we typically put absolute value symbols around variables from odd exponents from even roots, which would apply here. Because that part is kind of complicated, today what we're going to do is we're going to assume that all of the variables are positive. This way we won't have to worry about using absolute value symbols when taking roots. So today we're going to ignore the absolute value symbols. We're going to assume that all of our variables are positive, and that way we just don't plain have to worry about it. We're going to simplify a square root equation or expression, a cube root expression, and a fourth root expression. And similar to what we did in this first problem, we're going to break our problem into roots we know and roots we don't know. For example, I don't know the square root of 40. However, I do know the square root of 4. That was one of the square roots that we talked about up top here. So I could split the 40 into a 4 and a 10. I know the square root of 4, don't know the square root of 10. Because we're working with a square root, I can square root even powers. X cubed is bad, but I could take an x squared out of this and leave the extra x over here. Y to the 8th is already even. I'm liking that. Z to the 11th, not so much, but I could break that into z to the 10th and z. So when I square root the things I know the square root of 4 is 2. When I square root x squared, think of it kind of like division. This is like a second root, and if I divide x squared, the 2 here by the 2 here, I just get plain old x. When I square root y to the 8th power, it's kind of like dividing the 8 by 2, so I get y to the 4th. And z to the 10th, when I square root it, turns into z to the 5th. Again, kind of think about division. So these are the things I can simplify. I can't really do anything with the 10xz. I'm going to leave that underneath the radical symbol or the square root. And this is our final answer. For our second problem, we're taking the cube root of 54a squared b to the 6th c to the 11th. Again, we're going to break this up into a cube root we know and a cube root we don't know. The 54 I don't know the cube root of. That's not one of the cube roots I remember up here, but I do remember we can cube root 27, and 27 times 2 is equal to 54. So we'll split the 54 into a 27 and a 2. A squared is not something I can square root. There's not something I can cube root. There's nothing that I can multiply 3 times that would give me a squared. So we're going to put this here in the don't know section. B to the 6th, I can cube root because, again, think of, you can divide 6 by 3. So think of these exponents. Are they divisible by 3? If so, we'll put them in the no section. 11 does not divide by 3 evenly. The biggest thing I can take out of c to the 11th that I could cube root would be a 9. So we're going to put c to the 9th over here. To get to 11, we're going to need c squared over here. So when we cube root the things we know, I know the cube root of 27. Up here it says it's 3. When I cube root b to the 6th, think of dividing the root by the think of dividing the exponent by the root. 6 divided by 3 is 2, so that's b squared. c to the 9th divided by 3 is c cubed. So these are the things I can simplify. The things I can't simplify include this cube root of 2a squared c squared. And this is what my final answer will look like for this problem. For the last problem, we have the 4th root of 32, m to the 11th, n to the 16th. Again, we're going to split this into a 4th root we know and a 4th root we don't know. 32, I don't know the 4th root of. I don't know a lot of 4th roots, but I do know the 4th root of 16. And 16 goes into 32. So if I split the 32 into a 16 on this side and a 2 on this side, I know the 4th root of 16. Don't know the 4th root of 2, so that works. M to the 11th, I can't divide 11 by 4. The biggest thing I can take out of 11 that I can divide by 4 is 8. So we're going to split the 11 into an m to the 8th, where I know that, and an m cubed, which I don't. 16 divides by 4 evenly, so I can deal with an n to the 16th over here. And now I can start to simplify this 4th root I know. I know the 4th root of 16 up here, it's 2. When I divide this 8 by the 4, the 4th root of m to the 8th will be m squared. 16 divided by 4 is 4, so I can take the 4th root of n to the 16th power, that is n to the 4th, when I divide the exponent by the root. We're going to multiply this by the 4th root I don't know, which is 2m cubed. And now I've simplified all 3 of these expressions. The last thing we're going to take a look at is how you can actually multiply and simplify radical expressions, and we'll do that down here. A couple of notes about simplifying radical expressions. If you multiply 2 square roots together, like the square root of 2 times the square root of 2, you get 2. If you multiply 3 cube roots together that all have the same value underneath the radical sign, you get that number. So if you multiply the cube root of 5 3 times, you get 5. This is a problem where I have a 4 times the square root and a 6 times the square root. And what we're going to do is we're going to multiply the values on the outside. 4 times 6 is 24. And then I'm going to multiply the things under the square roots together. So I'm going to multiply the 5 and the 10, which gives me 50. X cubed times x to the 5th, add the exponents, that's x to the 8th. Y squared and y to the 4th will give you y to the 6th. Z to the 3rd and z to the 2nd gives you z to the 5th. We're now going to break the square root apart into things we can square root and things we can't. Leaving the 24 out front here, I'm going to start with things I can square root and things I can't. Don't know the square root of 50, but there is something that goes into 50 I know the square root of, and that would be 25. So we're going to take that 50 and we're going to break it into a 25 under something I can square root times a 2, which I can't. Even exponents are good. I can square root x to the 8th. I can square root y to the 6th. Can't square root z to the 5th. Z to the 5th is an odd exponent, so I'm going to take out the most I can, which is z to the 4th. 4 divides 2 evenly, but I'm going to have to put a z over here. When you simplify this out, you're going to have 24 right here, we'll square root the 25, that's 5. Square root the x to the 8th, divide it by 2, it's x to the 4th. Divide the 6 by 2, you get y cubed. Divide the z to the 4th by 2, that'll give us z squared. And out at the end here we have times the square root of 2z. When you simplify this problem, you can multiply the 24 times 5. When you multiply these numbers, you get 120. And we'll have x to the 4th, y cubed, z squared, times the square root of 2z. On this other problem, we have a 4 times 2 out front, that's 8. And then we're going to multiply these cube roots together. So I'm going to put the little cube right here. 4 times 6 is 24. A to the 4th times a squared is a to the 6th. B cubed times b to the 5th is b to the 8th. Similar to before, we're going to break this problem into things I can cube root and things I can't. Do I know the cube root of 24? Apparently not. I know the cube root of 27, which doesn't help. I do know the cube root of 8. That will help. That's 2. So I'm going to split this 24 into an 8, which I can cube root, times 3, which I can't. A to the 6th is good here because I can divide 6 by 3. Can't divide 8 by 3, so I'm going to need to make this b to the 6th power. And then what's left over is b squared over here. So the cube root of 8 is 2. When I divide the exponents, a to the 6th cube rooted is going to be a squared. Same thing for b to the 6th cube rooted, that's going to be b squared, times the cube root of 3b squared, which I can't do anything with. Finally, you can multiply the 8 and the 2, which is 16 a squared b squared times cube root of 3b squared. If you have embedded radicals, which is like taking a square root of a square root, I think the easiest way to handle this is take this first square root right here. If you were to square root the 81, which is 9, square root the x to the 8th, which is x to the 4th, and square root the y to the 12th, which would give you y to the 6th, we've done this first square root. But then there's a second square root, which means we need to square root this answer. And fortunately, we can do that. We know the square root of 9 is 3. We could square root the x to the 4th, and we can square root the y to the 6th. And this gives you a simplified radical expression.